I think we're ready to go.
At the University of Maryland, Michael Gollner studies wildfires for a living.
We've got an awesome whirl going on there.
And today, inside his lab, he's recreating parts of the Fort Mac blaze.
When I first saw the Fort McMurray fire, I mean, it's devastating. Well, large forest fire like this one, I mean, weather conditions that we have, which are very hot, very dry, with very high winds, you get incredible extreme wildfire behavior.
Extreme fire behavior is behavior that's fast and erratic, and therefore especially dangerous. But what happened within that fire to make it so extreme?
We're looking at things like spot fires, transition to crown fire, and fire spread. And the demos today relate to some of the experiments that we're doing to better understand the phenomena. So the term spotting refers to firebrands or embers, which are small burning pieces of vegetation that fly off the fire and eventually ignite new fires. So this is a very small scale demo, but if you imagine a forest with a couple 100-foot trees and thousands of them, the number of brands and the size of the brands is just incredible. There have been reports that these could be as large as logs or even trees flying out in some extreme fires in Alaska. But these small ones, little sticks, pieces of bark especially, can travel very far as those very, very hot winds loft them into the air and fly up to 9 kilometers ahead. These can land, ignite new fires, and that's a large jump for a fire.
In Fort Mac, spotting allowed the flames to leap over rivers and even ignite parts of the town before the main fire had arrived. It's a phenomenon that relies heavily on wind to make the embers fly and fan them once they land.
When a wind is blowing on the side of a house or a building, it's this L shape. It creates a re-entrant corner where there's basically whirls or this recirculation inside. It's enough to hold some of the fuel and give enough air to actually ignite these firebrands.
This mock-up house wall is made of flammable wood, but at first the embers just smolder away. Then add a slight breeze. The recirculating air causes the embers to ignite. Soon the wall is ablaze, and the current is forcing the flames inside the house. This is the unfortunate reality of life near the Boreal forest.
People are moving into the wild-urban interface where homes are butting up against forests that have been burning for centuries. It's heartbreaking to see this happening to a community, but at the same time, we know that it's inevitable.
As you've seen, wildfire and wind are a dangerous combo. And in the Boreal forest, they often lead to one other extreme behavior, known as crowning.
So what we've got going on here is a demonstration of transition to crown fire. So we've got this surface fuel, low surface fuel, which is simulating grasses on the forest floor. And on top here, you've got dried out pine needles. And these are simulating the forest canopy. And what we know is that if those flames could reach up and get into that forest canopy, you can eventually get a transition to crown fire spread. Crowning means it actually moves from the tops of trees, one tree to the next. That type of fire spread is much more rapid, much more extreme, bigger flames, very fast, and very dangerous. But as you can see, we have pretty decent flames here, even brands coming off of this, and it's licking those top fuels. Looks like it's not quite enough to actually ignite them.
A fire that burns under control is a forest management dream. It clears the forest floor of dry, dead litter and even undergrowth that could act as ladder fuels that wick the flames up to the canopy. Unfortunately, that's rarely the case in the Boreal forest.
So we're basically doubling the fuel load now. We should see a significant increase in the flame length. In Alberta, the boreal forests that are there do have a natural cycle of having some of these extreme fires. Where the canopy is very dense, trees are close together, it is naturally conducive to having crown fires. There is no real model to understand physically how a crown fire spreads so fast. But we know that it does. Up at the tops of treetops, there's a lot less drag from all of the forest litter down below. There are much higher winds which are pushing that fire on the top. There's some interesting dynamic as it's spreading through those pine needles, which have oils and other organic material, which is flammable. And so there's some combination there that causes these fires to erupt and be very, very rapidly spreading. And we're still trying to understand that behavior, which is why we do experiments in the lab still.
For those who study and fight wildfires, it's clear Mother Nature will never be beat. But the more this team can understand her today, the better our relationship with her will be down the road.
We want to be really careful because it's not that we want to prevent forest fires and wildfires in general. We want to be able to put it more into a natural ecosystem and around our communities, lower that fuel load so that we have very small fires, less intense and more controlled.